Oxidation number is the number of electrons that an atom loses or gains or appears to use when bonding with other atoms and compounds. If you consider the compound to be made up of ions, for example, sodium chloride is made up of sodium and chlorine with a positive one and a negative one charge, respectively. So the positive one is the oxidation state of sodium, and the negative one is the oxidation state of chlorine. Now, to explain the concept of oxidation number better, consider the example of carbon dioxide. Carbon has an atomic number of 6, and oxygen has an atomic number of 8. If I was to draw the valence electrons, carbon would have 4 valence electrons, and oxygen has 6 valence electrons. So I'm going to draw the two lone pairs like that. And other oxygen has 2 valence electrons here, 2 other lone pairs here. The lone pairs are known to occupy extra space. So these electrons form the two bonds. So each the carbon atom has double bond with each of the oxygen atom. Now, if I was to break this bond heterolytically, heterolysis, lysis means destruction or breakdown. If I was to break down this bond, hetero means if one atom was to take away all the bonded electrons. In this case, oxygen would take up all the bonded electrons. How do I know that? If you look at the electronegativity values, oxygen has a value of 3.4. This is the table of electronegativity or the electronegativity values on Pauling scale developed by Pauling. So oxygen has 3.4 and carbon has 2.6. So oxygen is more electronegative. Oxygen is able to pull the bonded electrons towards itself better than carbon pulls the bonded electrons. Therefore, if I was to break this bond in a way and say that one atom takes away all the bonded electrons, even though these four electrons were contributed by carbon, oxygen being the most electronegative element would take away all the bonded electrons. So these two extra electrons that came from carbon gives oxygen a -2 charge. And similarly, this oxygen gets a -2 charge. In order for this molecule to be neutral, carbon has to have +4 oxidation state. So that explains the concept of oxidation state in the case of carbon dioxide. Now, what is the use case or what do we do with the oxidation numbers? We can find out whether a reaction is oxidation or reduction using oxidation numbers. The mnemonic here is oil rig. Oxidation is loss of electrons, whereas reduction is gain of electrons. Now, when you lose electrons, your oxidation number increases. And when you gain electrons, your oxidation number decreases. If that doesn't sound clear, let's look at an example. Hypochlorous acid plus hydrogen sulfide gives you a hydronium ion plus chlorine plus elemental sulfur. Now, if I was to put the oxidation states, oxygen has a -2, chlorine has +1, hydrogen has +1 again. Although there are two hydrogen atoms, I'm just stating the oxidation number for each atom here. Now, hydronium ion +1, oxygen will have -2, chlorine has -1, elemental sulfur has 0. How do I know the oxidation states? There are rules for assigning oxidation states, which I will discuss in the next video. But for now, these are the oxidation states. Now, as you can see here, sulfur goes from -2 to 0. Therefore, for sulfur, oxidation number has increased. Therefore, by our definition, if oxidation number increases, then it is oxidized. On the other hand, if you look at HClO, or hydrogen sulfide is oxidized. HClO is hypochlorous acid. If you look at chlorine, it goes from +1 to -1. Therefore, the oxidation number has decreased. By our definition, if oxidation number decreases, then hypochlorous acid is reduced. Therefore, hydrogen sulfide has been oxidized and hypochlorous acid has been reduced. That's the concept of oxidation number.